Hi, I'm Dr. Shahriar Hussain. I'm running a data science workshop series for a small group of experienced professionals who have at least a computer science bachelor's degree. Some of them have business and administration backgrounds. All of the participants have more than a decade of experience in the software and information technology industry. Most importantly, all of them are interested in knowing more about basic data science technologies. Since the participants are already proficient in multiple programming languages, my objective for this workshop is to demonstrate the capabilities of the data science packages already available with Python programming. When required, I give a brief description of an algorithm and the theory behind it. And then I quickly move forward to the coding part because this audience is tech savvy and does not need any gory details of many of the items. To maintain the participants' privacy, I have removed all my discussions with them. I created a voiceover for these videos. Let us see what we discussed in the workshop. Python has ample packages to help data scientists, analysts, and practitioners. We are starting with NumPy, Pandas, and scikit-learn in this workshop series. NumPy and Pandas provide the basic functionality of data pre-processing. One can say that these two packages, NumPy and Pandas, help in processing and exploring data programmatically. Instead of using Excel-like spreadsheet software, one can use Pandas to explore and clean data before applying any machine learning algorithm. The package scikit-learn provides a rich suite of machine learning algorithms. TensorFlow is another widely used machine learning library developed by the Google Brain team. PyTorch is another such package for machine learning. Facebook developed it. If anyone starts to work on neural network-based projects, I would recommend TensorFlow because it is widely used and a lot of documentation and community forums are already available to seek help. I would also note that PyTorch is also growing quite fast. It will likely be more popular in the coming years. In the description below, I will provide a link to an article where I outlined each package listed here on the screen. NumPy provides a flexible data structure with basic mathematical operations. An arbitrary number of dimensional arrays can be handled using NumPy. NumPy is a popular library for keeping data in multidimensional arrays. The Pandas library is built on top of NumPy to help explore and preprocess data. I should mention here that most of the prepackaged data science algorithms available with the libraries will require data in tabular form. In a separate video, I explained more about tabular data. I'll provide that link in the description section. Okay, we have to bring our data to tabular form before we can apply these tools. If we have text documents, we have to make sure that we convert the documents to tabular form. One example of conversion of text data to tabular form is each row of a table represents one document. Each column shows how many times a word was seen in that document. In reality, the conversion of text documents to a tabular form is much more complex, but I am just giving a simple example here to clarify the concept. The summary is we need tabular data to make sure that we can use many of the algorithms already available with the packages. NumPy helps us in keeping the tabular data in the main memory and apply mathematical operations. To demonstrate examples of NumPy, I used Google Colab. The website colab.research.google.com provides a Python editor. The use of Google Colab is convenient because the audience can easily practice what we are discussing without worrying about having Python to be installed on the local computer. As a regular Python list, I am creating a variable named list1, which contains 5, 2, 10, and 3. Since Python is an interpreter, I can run code line by line. From a line in Google Colab, I press Shift Enter or Shift Return on a MacBook to execute that line. To see the content of a variable, I can simply type, for example, here list1 and then press Shift plus Enter to see what the content of the variable list1 is. If you are using Jupyter Notebook, you will have a similar style. If someone is using a regular Python editor like Spyder, then